Hey, Josh.
Hello, everyone. Welcome to a new edition of Advent Code with Juan and Jess and the team
Yoo-hoo!
at All Zero by Alta. Hey, Jess. Thanks for joining
Hi,
your stream today.
Juan. Thank you.
Yeah, this has been awesome. This is
I'm so
my first
excited.
stream, actually, solving Advent of Code live. I have successfully submitted 8 days. I'm a little bit behind, I know, trying to catch up. Some of those days have been very challenging. Some of them were easy. I'm really excited to see what we have today. So today we're
Dude,
gonna be working on day 9. Like, how do you feel about
you were saying you were a little behind and you are like
it?
resolving day 9. I stopped on day 2.
Hey,
But I guess
everything
life
counts.
happens.
Everything, life happens. Yeah, I know. This year hasn't been easy at all. It has been quite complicated. Yeah, I gotta say. Some days I struggled quite a bit, and I'm glad I didn't go live those days because I had a widescreen for a long time. But if it
Happens
gets
to
too
the
hard,
best of us.
we can always create a guide or something, right?
I
No,
mean,
but
yeah.
that's not that's not the idea for today. So let's get started. Let's introduce the topic. Let's introduce the challenge for today, day 9. I'm gonna share my screen and I'm gonna start working on this. The one thing that I had to highlight before we get into the details of Advent Code and how we plan to solve this is that I read not like a normal person. A normal person reads left to right, top to bottom, right? When it comes to challenges and reading on the web in general, I'm kind of like a middle reader. And so I start always somewhere here where I see kind of like code snippets or inputs, and then I go up and down. I know it's super weird, right? It's kind of like my mind works. So if I'm not doing something straight, let me know so I can fix myself, and I'm like back to human mode.
I'm here. I'm
I
here
do
to
kind of
help
like
you,
a
Juan.
binary search. I go to the middle and then I split in sections to find the relevant stuff. It is very helpful most of the times, but a lot of times I also forget to read important stuff, and then I'm like, after half an hour fighting with a challenge, I'm like, yeah, that's why I skipped that part. So it's good because it takes some shortcuts, but yeah, definitely not good when you need to when you miss important details.
Juan,
So yeah.
can you zoom in on your IDE? Like, I guess it's very
Yeah.
small font.
Yeah, so I zoomed in on the text.
Yeah.
So I'm not sure if I can zoom in on the folder structure on PyCharm, but let me open
I guess
this
there is
screen
a
as well.
zoom thing, like property zoom, some sort of thing that should be able to do it.
Yeah, let's do Visual Studio Code because it is way better to zoom in, right? Is that
Yeah.
better?
Yes, thank you.
Cool. Yeah. All right. So before we
Also,
get started,
I just removed
have my
your thing from stage, your screen share. You might want to move your stream tab out of the shared one, because if you need to
I only
chat
have one.
or something. Do you have another screen?
Not pulled up right now.
Yeah, I guess you can put it up, because if you want to chat or something or make a comment, it's easier.
All right. I'll see how can I do that.
Yeah, I just removed your shared screen. We can chat while you try to do that. Not a problem.
All right.
So have you been doing that this has been hard? Because I remember I've been code hard before when I started like, in the past years, but not this hard. Like I'm seriously struggling with it in a way that I did not expect to happen. And I kind of got glad a little bit because I was talking to other developers online and they said, "Oh, it has been hard. Like it has been taking me solid few hours to get problems solved on a day." And I was like, "Oh, interesting." And then I was like, "Oh, thank God it's not only me."
No, it has been difficult. Yeah, absolutely. Um, I'm gonna reshare my screen. Let's see if now that works.
Great.
All right. Yeah, see, when you're new to streaming, this kind of thing happens all the time.
We are here to figure. Oh my God, what just happened? Oh, I know what happened. I updated my software. Oh, my camera froze. Great. So my camera doesn't know how to handle this. But like I updated my OS to Sonoma. And now what happened is it has reactions.
Oh, nice. Yeah, those are pretty nice.
Let's see if it works.
Oh, there we go.
I love it.
I'm still in an older software version, so I can't do that. But I have my update pending. I have to.
But my camera freezes, so I don't think that's a good thing. I don't think StreamYard is prepared for this.
Yeah, absolutely. All right, so I think now the screen is readable, right?
Yes.
Is that a good size?
I guess so.
All right, cool. So we have the challenge ready, we have our editor ready, and we have our coffee, essential for solving challenges.
Mine is here because it's very early.
Yeah. This turns, my body turns coffee into lines of code. So that's how it works. All right. So, let's start with quick wins, right? Who doesn't love like a quick win, like creating your folder?
I love quick wins. Quick wins for the win.
So, this is the same code that I'm using with my repository, which I'm gonna share here on the chat. But this is where I'm hosting all my solutions, and we will have day 9, hopefully at the end of the day, in there as well. So I'm gonna create a new file, main.py, and we're gonna need our input.txt. Not necessarily, but we're gonna copy and paste this, which no, we are gonna read.
We are going to read.
We're not gonna copy and paste before reading. All right, so yeah.
I know. I copy and paste.
I started already with my binary search.
Yes, I copy and paste everything like first as well. For me, it's like the way to begin is to start having an input file and then have a main.py. I don't.
Yeah.
I understand that.
Exactly. All right, so you ride the camel through the sandstorm and stop where the ghost maps told you to stop. I feel like I'm reading to my kid at night before he falls asleep. The sandstorm subsequently subsides, somehow seeing you standing at the oasis. All right, so this is just the story. And then I guess the important stuff starts here. You pull out your handy oasis and sand instability sensor and analyze your surroundings. The oasis produces a report of many values and how they are changing over time, your puzzle input. Each line in the report contains the history of a single value, for example, and then we have this sample text that we have also here on the screen. To best protect the oasis, your environmental report should include a prediction of the next value in each history. To do this, start by making a new sequence from the difference at each step of your history. If that sequence is not all zeros, repeat this process using the sequence you just generated as the input sequence. Once all the values in your latest sequence are zeros, you can extrapolate what the next value will be and the additional history should be. So it's kind of like a recursion problem today. That's interesting, right? Because they're talking about repeat a process and the result you generated is now an input in that process. So
I don't
this is
know
a
if
classic
it
example of
is.
recursion.
Yes, I don't know if it is only me, but like I have problems with recursion so much.
I don't like recursion, so we're gonna solve it without. But this is a typical recursion problem.
Yes,
we're gonna
because
solve
we
it
factor
without.
it after, if we have time.
We're gonna try to resolve it.
Yes.
All right. So in the above data set, the first history is 0, 3, 6, 9, 12, 15. Because the values increase by 3 each step, the first sequence of differences that you will generate will be 3, 3, 3, 3. Note that this sequence has one fewer value than the input sequence because at each step it considers two numbers from the input. Since these values aren't all 0, repeat the process so we know the condition to stop. The value differs by 0 at each step, so the next sequence is 0, 0, 0, 0. This means you have enough information to extrapolate the history. Visually, these sequences can be arranged like this: 0, 3, 6, okay. It's like a pyramid, right? And of the differences corresponding to the previous array. And each array decreases its size, right? Because you start with you start with an array of length 6, then you have 5, and then 4, and then you have all zeros, and you reach to the end.
It looks cute.
It looks
when it's printed like this, because you get
cute.
to visual representation.
Yeah.
I like it.
Yeah. So the first thing that I think of, right, because if we need to extrapolate, the first thing that comes to my mind is linear recursion.
Is that the first thing that comes to your mind?
Yeah, I'm weird.
I gotta tell you, it's not the first thing that comes to my mind. I gotta say, it's just like how, why, and I don't know if I like this. And then recursion in probably 10th place.
Yeah, we need to continue reading because probably will not be as easy.
This is one of those long ones.
One of the premises that I have in all the challenges that I solved so far is I don't want to install any packages, right? And implementing linear recursion, though it's not too hard, it probably will be as hard as having the same, as processing the way they do the pyramid, right? It's not gonna be much differences. Oh, we have Corey here in the chat. Hey, Corey.
Hey, Corey.
Recursion, yeah. We all love recursions. I love them. And we're probably also gonna have some regex. I know Jess loves those.
Dude, I guess this day is going to be rough. It has regex that I don't particularly like. It has recursions that I'm not very fond of. Yay!
Well, we'll see. I mean, this file is very easy to process so far, so we may get away without using it. Reminds me of square root. Yeah, I'm pretty sure that it's a simpler solution than brute forcing our way through recursion, and we gotta think about that.
Hey, let's do it. Let's jump in. Yeah.
Let's continue, right?
Because,
okay. So to extrapolate, start adding a new 0 to the end of your list of zeros, because the zeros represent differences between the two values above them. This also means there is now a placeholder in each sequence above it. All right, so you basically extrapolate each one of the sequences, and then you start filling in right from the bottom. So yeah. So you start with 0, then you add the 3, and then the 3 you add to the 15, and you get your result, which is 18. Finally, you can fill B, which needs to be the result of increasing 15 to the value on the left. Okay. And then here is another example. Finding all zero differences for the second history requires an additional sequence. So here we have another example, and now finding zeros requires 4 different calls to this recursive function or loop that we're gonna have. And then following the same process as before, all right, so we have Steve here on chat. This process was invented with the idea of machines that will not be capable of recursive calling. It was designed to tabulate polynomials using simple theoretical machines before modern computers existed. Yeah, we're gonna try to solve it without recursion, but we'll see how it goes. I mean, honestly, I'm still thinking about your comment. Quite a good observation. So, yeah, let's see. This makes me think a lot about writing assembly. How people's minds deviate and wonders, it's something that amazes me. Because
Juan,
I may not have think of linear recursion, but
Yes.
assembly? All right.
So funny.
I need coffee.
Yes, maybe you need more coffee.
Yeah. I think my caffeine levels are not yet to that task.
Nope. Not mine.
So
Like
following
I just
the
jumped
same
out of
process
bed like 1 hour ago.
Oh God. Yeah, that's tough. Thank you for being here so early. Thank you for that.
You know, everything for my friends.
All right, so this is just another example of the same. All right, so the first thing that I like to see, so clearly we need to compute this highlighted color, right? And then we need to do some operation. Normally involves like summing some stuff.
Though, is it feels like this input would be something like comma separated like lines instead of like each line has the value of the thing though. I would take a sneak peek at the input file they have on the end of the problem just to make sure that like we have the same format. But other than that, it feels like this is going to be fun.
Yeah. So
that example that you copied is the example on the top. So like it doesn't have the results, right? It's just like the one line has.
This is the example, and honestly, it's like super easy to process. I just need my line to open a file.
Oh, you know what I did? Just a comment there is I made a little module because I realized I was copying the code for reading the file all the time. So instead of like copying the code, I was like just import it. Like a choose.py file.
So the first thing we can do, right, is so we read the file and then we do line split. So for line in lines, and then our numbers will be line.split, right? And if I can now open a terminal here, where is the terminal? Terminal. New terminal.
Is that button on the top corner there? Yeah, I don't know. I always click the button.
Yeah. I found it. All right, and we're gonna do Python 3. We need to be in the right folder. So cd09, d09, and then Python 3. Main.py. And now this is crashing because this is file. All right, so for line in files, we're gonna read and we're gonna split. And then if we print numbers, we're gonna have the numbers as a string, right? So I need to put this a little bit smaller because otherwise I cannot read. Yeah, so we have the numbers as a list of strings. So now we can map int, and then we can get a list of the map because this is Python 3. And now we have a list of numbers, right? So this is a nice trick to convert strings into numbers. And because we are using split without any parameters, it splits with the spaces, which is exactly what we need here, right? So we don't need regular expressions, at least to parse the file.
Yeah.
So first,
So far, like I wouldn't do regular expressions, but I definitely wouldn't use map. I would use a list comprehension to
oh,
loop
yeah,
over
you can do that
and
as,
convert. Yes, I
I
guess
mean,
it works the same way, but since like because these are small files, map would be probably be more performatic than list comprehensions would be with bigger files, I guess.
yeah, I guess you could do something like this. It probably does the same result, right?
Yeah, I'm assuming.
Yeah,
Yep.
yeah, it's the same. Yeah, I mean, I'm not sure which one is better, to be honest.
Yeah, so it depends on the type of input that you have. Like if you have like huge files, map is going to be better than the list comprehension, and the list comprehension is going to be better than a for loop, pure for loop.
Right.
So that's
Okay,
how
cool.
I would do it. Yeah.
Mm-hmm. Yeah, well, we have our list, right? And so one of the first things that I like to do with these puzzles is I like to focus on one at a time. So I'm gonna delete the other two use cases because they just make noise to me at this point, right? And now, yeah, and now we have the first sequence. So map and a generator comprehension will be generally identical. Okay, cool. That solves it. Thanks, Steve. All right, so we have our list of numbers. So the first thing that I like to try to think about is how can we cheat? Because the easiest solution will be to process every single line, right? Like take this line and do the subtractions, and then take this line and do the subtractions until we finish, right? But we will have to process all the numbers. Like, do we really need to process all the numbers? What happens if we process only the last two numbers, right? If I process the last two numbers, I will get these three, right? But I will not get these three. So I couldn't calculate the zero. So I will have to calculate the last three numbers in this case. If I calculate the last three numbers, I could have this number, I could have this number, and that will give me the result. So in this particular exercise, calculating the last three numbers will be enough to reach to the conclusion. So processing the first three, it's completely unnecessary, I think. But let's see the other example, because they have another example here, which is this one, where the distribution is different, right? Because in here we have the distribution is increasing one at a time per number, right? And so if we want to calculate the 28 here, we will need this 6, we will need this 5 to get to this 1. But to get to this 5, now I need this 10. Well, this is gonna get complicated because we need to know how many levels we need to find the solution to know how many numbers we need to process to calculate the result. Right? Like we don't need the whole pyramid. In this case, we will be fine from 6 onwards, right? Like we just need this pyramid right here to calculate the result. Yeah. While in this case, we just need this pyramid here, right? So the base of the pyramid is equivalent to the number of the depth of the height of the pyramid, right? That's the only thing we need to calculate. So in this case, we need to calculate this 3 or this 3 because it's step 3. And in this case, we need to calculate, what was it? In this, we need to calculate 4 because the pyramid height is 4. The big question is, how do we know the height of the pyramid before doing all the calculations? Do you follow me so far?
I do, but at the same, I have a problem when I'm reading a puzzle like this. Is like my head goes directly to try to solve the
Oh,
happy
well,
path for the first solution.
let's try a happy path, right? So one thing we know is this is recursive, right?
Yes. So,
Now
for
recursive
example,
functions,
Steve, that is
yeah.
in chat, saying, very math person, saying like you have to know that the derivative becomes zero. So you have to
Mhm.
do the full discrete derivative at each step until it becomes
Yeah.
a flat line. But this sounds overcomplicating it. But it
No,
makes
I
sense,
mean,
but I guess it's overcomplicating it. The way that I would do it, I would take the first three numbers, I would subtract the first two and see if the gap in between the first two and the third would be like the same. If not, I know that I would have to do a second line and continue on from there. But also, I would be using PyTest or some sort of like unit testing so that I can do this in
yeah.
a regular way, because this feels like to me like the best way is like if it does comply with like increases in the same progress, like the progression is the same, it makes sense. But if you have a line that the first two has a gap, the third and the second also is the same gap, but like the fourth might not be, then you get like complicated situations. And that's where I always struggle with like past puzzles of like admin of code, is like the border cases, where sometimes like the gap might be the same for the first three but not the same for the fourth compared to the third.
Hmm.
Does that make sense?
Yeah. Yeah. So,
News.
okay, I don't know why I
Sorry.
created that because it's confusing me more. So what I'm thinking now, right, is so we start with a prediction. In our prediction, so this is where we are going to accumulate the last column, right? Because of the last, I don't know, what is it, the side of the pyramid?
Yeah, I would say.
And because like to get to 18, right, so we need to calculate the 15th plus the 3, right? Plus these 3. So we
Okay.
always take so at the beginning we take the 15 for the first row, then we take the 3 when we process the second row, like Steve was saying about the derivative, right? So for the derivative, I guess we have to shrink our list, right? So numbers, and on each iteration we have to shrink the list, and to shrink the list we can do a simple numbers from 1 to -1, right?
Yeah,
And
like
then we need to
the
calculate
two
the
last
differences.
ones, right?
But yeah, but if we need to calculate the differences, because we need to convert this into 3, 3, 3, 3, 3, 3, 3. Right? So what I'm thinking, have you ever used operators?
Which ones?
Like subtraction, for example, in an array?
No.
This is quite interesting. Right? Look what happens this. So let's take it step by step. So now I can do map, right? I love map. And then I can say
I can tell.
dot sub, and now I can pass numbers, and we need to pass. So let's print this.
Yeah,
we always need
you
to
have
convert
to.
map. Yeah, Python 2, everything's Python 2. Okay, so subspecs 2 arguments. Okay, we need the 2 different arrays. So one that goes from 1 and the other one that goes up to -1, right? Because we want to calculate the differences between the left boundary and the right boundary. Minus.
Yeah, that's what I was going to say. Yeah.
So now we have our 3, 3, 3, 3, 3. How many 3s we have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, this is great. So this calculates the next step of our pyramid. Yeah?
Yes. And then you can make sure that like all of them are the same.
Yeah. So now what we can say, our new step is this one.
I would say put an if in there. Like if numbers are like all the same, and then you like compare, probably using count and length. If they are all the same, you can just return that. Like the next one would be like 0, 0, 0. You already know that. Like the step is 3, right? So you can return the step. Isn't the step
Technically.
what is?
Technically, I only need to. It only matters if the last one is 0.
Yeah, so you just need the last one.
So I can say if numbers -1.
You should probably save the last one somewhere.
Well, I can do this, right?
No, because you're updating the list every time. Aren't you? You're updating the list. Yeah, but that one will give you 3 instead of 18, 21, whatever the one. I don't remember.
Oh,
15.
Because then my prediction starts at numbers -1. Yeah, you're right. I need to say that.
Yeah.
So and then if it's 0, we break. And if not, our prediction.
I wouldn't break. I wouldn't compare to 0. Like my mind is going like this. So if the line is already stepping from number to number in like equally, so 3, 3, 3, 3, 3, we already know that the next one's going to be 0, right? So I don't need to calculate 3, 3, 3 minus 3, 3, 3 to know that the next one is 0. If everything is equal, we already know that that one is already like the one before the last. Does that make sense?
Yes.
Oh my God! Stop.
But that is painful because then I need to do like the set of numbers, the len of the set.
Yes.
It should be if it's equal to the len of numbers. No. The len of set of numbers needs to be equal 1.
Yes. The set, because the set is going to give like only one. It's going to give you the numbers without repetition, right?
But not necessarily.
Can you do on your terminal? Can you do like set of a list of equal numbers, so people know what you like doing?
Oh, what should I do?
Just run on Python like set of 333. As a list.
So set of 333 will return will return
a set of
len
1. Yes, that's what I'm saying. So if it is len 1, you already know that the last number of the line you started with, like the last number of like the prediction that you have, is the one that you need.
Yeah, but coming back to the point of the derivative, right? What matters is that between the last two inputs, the tangent of the last two numbers is 0. It doesn't matter that the tangent of all the other numbers is 0. What I mean is the first time we encounter a 0 on the last index is enough, right? So you can have 5, 6, 2, 1, 3, 3, and that, because you have 3, 3 at the end, that will be enough.
Are you sure?
Does it make sense? I mean, it's a curve.
It makes sense. Like what I'm saying is, I keep thinking that there might be a line in the input that they give us that might finish with like the repetition of a number, but not necessarily be the gap that it needs. For some reason, I keep thinking that it's going to happen. That's all I'm saying. It might not be the case, but like that's all I keep thinking. Does that make sense to you?
We can try. We don't. I mean, worst case, it doesn't work, right?
Yes.
So now let's print prediction, because I honestly
I don't even know if for now. Sorry about that. So Corey said, sounds like a good idea to write out the algorithm in comments.
Yes,
and then implement.
We are not very clear about the algorithm yet.
Yes.
What we know is that we need to shrink. So we need to we need to calculate next level of the pyramid, which is the sum, which is the difference of all the elements with the next. Yeah. And then we are unclear when to break. And then the prediction will always be like, for the prediction, we always take the last number in the row, I guess, in the level.
Yeah, I will move that comment up when you instantiate the prediction, because we might not need to update the prediction though. Do you?
Oh, we need to.
We do?
Because we are always overriding numbers, right? We are not creating a matrix.
But you don't need to update the prediction. The prediction is going to be the last number or the first row that you do. Always.
No, you always need to add, right? Like, for example, in here to get to 18, you need to add this 3 plus this 15.
No.
So we start
with but 15. It's always the last number. You don't need to sum anything. In that case,
it's the sum of all the last numbers. Like, for example, here, 21, the next prediction will be 1 plus 6 plus 21. 28, right?
I'm confused. Give me a second.
This is the prediction. So when you start with this array, right? It's 1, 3, 6, 10, 15, 21, right? So
yes.
the last difference between these two is 6, right? But here you have a 1. So now to get to 28, you need to do 21 plus 6 plus 1. That will give you the 28. That is the next prediction.
I'm so confused. Okay, wait. Finding all zero differences for the second history requires additional sequence. So then following the same process as before, work out the next value in each sequence for the bottom up. Oh, okay. I thought the prediction was always, oh my God, I was so confused. I thought the prediction was always the last number of the first sequence, and you always were going to have the first sequence, but I forgot that in the second line of the example that they give us is not the case. Okay, got it. Yeah. Sorry. You were right, I'm wrong.
It's not about that. I'm still don't know what we're doing. But this is how it works, right? We bounce ideas, we try stuff, and eventually we get it right.
Eventually, we might arrive at a solution.
We are close. Look, we got 15. Not very promising, but this is because we are breaking too early. Or we are missing to calculate something, because we said here, in your condition, I think it's fine. I'm just worried about that edge case where...
Yeah.
Like, for example, right, let's... like, you can have something like minus 11 here, right?
I don't know if you can.
Or let's get something like, because this one starts in 0. Let me start a new one.
Copy the second line. I guess the second line is a good example.
I'm not sure. Well, we can try. So we have this. In this case, they all end in 0 at the same time. I wonder if this is always going to be the same. Always going to be the case.
It sounds like it.
I'm not sure. Like, what happens if I have 1, 22, 23, 24, 25? Yeah?
What would be the gap in that case?
So, in this case, we will have 0. No, we will have 21.
Yes.
1, 1, 1. Right?
Okay.
And then here we will have
20.
No.
Minus 20.
Minus 20, right?
Yeah.
Minus 20. 0, 0. And now the next result is 26. And we
I
finish.
see your point, because you sum like 1 to 25 and then you have 26.
Right, we are finishing because there's a 0 here. Doesn't matter what happens here. It's because the
So
only
you
numbers that matter.
grab the last number and make sure that the last number of whatever row you end up with is 0. Okay.
Yeah, and this is coming back to the pyramid, right? In this case, the pyramid has 3 levels, so the only numbers that matter are these 3.
No, I see your point. You know what I would do? Like, I would do the brute force way, probably, a little bit silly way, which would be calculate the whole pyramid for each line and see how long it is, and store that in a matrix or some sort of matrix. Not necessarily matrix, because it has to be like the same size, but like a list of lists.
Mm-hmm. Yeah, we can do that as well. I mean, I'm overriding because we really don't need all the numbers. The only thing we need.
Yeah, you don't. Yeah,
you just need one.
So, okay. So what I would do is, instead of like having the prediction be like a number, I would say the prediction is to be a list of the last numbers for each one.
But then we need to sum it.
Yes, you already sum it. That's what you were trying to do, right? With the updating of the prediction.
Yeah. But let's build the list because it's gonna be.
Oh my god, I'm so slow. Divide. I'm so sorry. I just
no, that's fine.
I got to your point where like you need to update the prediction now.
Let's see the list, right? Because it makes more sense. So we have now the 15 because we know we are breaking too early. So I think we need to break when we see a 0 on the last.
Oh, I did I lose your sound? Is it me? Sorry.
Item, right? So if numbers minus 1 equals 0, we break. Doesn't make sense to continue processing. And now we have the 15 and the 3. So our prediction will be the sum of that, right? Which will be the same thing as accumulating, right? But this is more visual.
It makes sense. Try to do the second line to see what it gives out as a result.
Yeah. Right, so let's keep them all. And if we run again, we should see now 3 different results.
Yeah,
with the
18,
solutions
28,
for each
68.
one.
Yes.
Yeah, but not the sum. Let's just print prediction. So now we have 15 and 3, which is a solution for the first. 15 and 3. Then we have 21, 6 and 1, which is the one we were discussing here, right? 21, 6 and 1. So the sum will be 28, which is our solution. And the last one, they don't say it, but they say the value of the third history is 68. And
so there is a 45 there, they shouldn't be there. Yeah.
The sum of this should be 68, right?
I don't think it
68.
is. It is?
Yes.
Oh, the 45 is the last one for the first. Oh, never mind.
Yeah, we can also do some prediction, right? So we can print out, 68.
Oh, look at that, so cute.
And now the sum of the 3 is 114. Should be 114.
Nice.
Right. I still don't like the break. Yeah, it's completely unnecessary. But
I would say run for the whole input and see if the answer is right. I think it's not going to be, but
could it be that you don't reach a solution? No, you should always find a solution. You should always get to zero.
Put the line that you put before. Put the line like the 1, 22, 21, 22, blah 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 that you had before as well. Because the one we can also calculate in the example.
In the example, this one.
Yeah, we had that one that we had in the example. Put that one on the input and see the result. Without the 26, remember.
I don't know.
Without the 26.
26 and 1, 27. Yeah.
Because the line was supposed to end at 25, and then you just completed the 26.
Yeah. It's fine.
Yeah. It works. Run for the whole
It
input,
works.
just for the sake of it.
It works.
I would.
It is still not optimal because
We can refactor if it's not right. If it is right, because I think it's not right. It is going to be like an edge case that we cannot think of.
all right. So now while
Like if the line is whole 0, 0, 0, what is going to happen? Like
the
two
line
zeros
is
in the line.
2 zeros here.
No, the line is whole, like full zeros, only zeros, like 0, 0, 0, 0. It should be
It
zero.
should give
like,
0.
Yes.
It should return 0.
Yes.
It returns 0.
Good. But what if you do
I don't know
like
why.
what if it ends
but it
in
returns
0?
Yeah,
it makes
ends
sense
immediately.
because if you do 0 minus 0 is going to be 0 still.
What happens if you have just one input?
Yeah.
I think we break it because.
Yeah.
Well, no, this shouldn't break.
It's going to be like the only thing. Yes, it breaks.
Ugly. Yeah.
Because it's not a list. Is it a list? If you put like
well, it's a list without items at this point.
Yeah.
Let's open Python here, right? Again, Python 3. And now if I create a list A and I assign only one number.
Yes.
And now I do this list. The same
That's
operation.
Why I use IPython. IPython is much friendlier for typing like things like that.
I know, but I'm not even in a virtual environment here.
I know. I get it. I'm just being annoying.
So that one is an empty list, so we have nothing to process. But that's something we can remediate.
Because the sum of like the number alone is going to be the number.
Yeah. But we can remediate, right? The first thing I would like to do is to pass this here.
I would do an if before the prediction. If like the number, the list, the line is like length 1, just return the number.
And the number is already stored in prediction.
Yeah.
I just need to break.
Yep.
All right.
Try again.
What
you need to open your terminal though.
Oh, I closed my terminal. Okay.
Yes.
Exiting Python on Visual Studio Code is like exiting Beam. Oh, okay. I'm not on the folder. No, nothing bad.
Yeah. You know.
Yeah, there we go.
Yeah. Ooh.
So now let's move this inside the while condition.
Okay.
I don't know.
You don't like the while true?
I don't like breaks like this when I'm
don't like
unnecessary. It's hard to read.
And for me, it's like a last resort. Like a last resort. Like if you don't have any other way of breaking that loop, you probably need to refactor your code.
Yeah, but in this case, it should be easier, right? We just copy this stuff and then we invert it. And we say if len of numbers is greater than 0, that would be the opposite of equals 0, and numbers minus 1 has to be greater than 0.
Comment out the len break thing.
And now we say here we loop until the pyramid is complete, or the last number of the level is 0, which means the tangent of the curve is flat.
I guess if the person would read your code and read tangent of the curve is flat.
Okay.
Without having the context of this live stream, they will probably not know what you're talking about. Because I don't expect everybody to remember all of those things like I'm speaking for myself. Like I wouldn't make the connection by myself.
I see your point. I think my camera went off.
Your camera went off. Yes. Let's see what they say in the problem. Okay, so in the above that said, the first history, blah, 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 values increased by 3 in each step. The first increase, blah, blah, blah. Since the values are in all 0, repeat the process. The values differ by 0 each step, so the next sequence is 0, 0, 0. This means that you have enough information to extrapolate the history. I would say you change the tangents to extrapolate the history. We missed your screen. Did you?
Yes, I'm fixing that. Yeah, for some reason it's froze the camera and screen. All right, so
weird. Like there, when you say like if the last number of the level is 0, means that we have enough information to extrapolate the history. That's what I
also like Steve's comments. We can add a link to Wikipedia.
I mean, you can, but
I mean, it is a linear. It is a curve made of lines.
You're forcing people to learn math. They might not want to do it. I would say use the terms they use in the problem, which will make sense to people, even though if they might not know the math.
Right,
and you can add a comment in the end saying like, hey, when we were solving this, we thought about X, Y, and Z concepts. You might want to look into that or whatever.
Right, thanks, Corey
says he needs to hop. Thanks, Corey. Have a good meeting. See ya.
All right, so it's 0, which means we reached to the end.
Which means you can extrapolate the difference, the history. Oh, Jesus. Extrapolate the history. Yeah. You'll want to put the tangent in. Oh my God.
Because I think it makes if you think it like that, it makes a lot of sense and it's making it very easy. There's nothing else to think about because from now on
I'm just annoying you and probably Steve a little bit.
It was Steve's idea. He corrupted the live stream.
It's always your fault, Steve.
But I'm also very mathematical, so I like that analogy a lot.
I mean, yes. It reminds me of calculus classes and whatever one that I had that in. I don't remember anymore.
And I'm pretty sure that if we calculate one of the extremes, coming back to this example, right? Like we have the local maximums and the minimum maximums in calculus. I'm pretty sure that if we find the maximum points, then we can build a pyramid based on the maximum points and not the whole pyramid. Because the only thing we need to take is the last local or the last minimum. So the last local point, whatever is a maximum or a minimum, and calculate the pyramid from there instead of calculating the whole thing. But we're not doing that because I don't remember enough to do that.
Steve says the code is a difference engine whose purpose is to tabulate polynomials. The thing is, Steve, you were assuming that people might know what polynomials is, and that might not necessarily be true. Maybe they didn't go to college and didn't learn about polynomials in college, and because of that, they only can figure out like the visual representation of the thing. That's my only point on skip the tangent comment. Like,
Yeah. No,
but it makes sense. Like for me, it makes sense because, I learned polynomials a long time ago. It has been forever since I used it, but I remember. So I can understand what you're saying.
Yeah, cool. So we have the solution for all the lines now, right?
Yes.
So the one thing I would like to do, I'll restart the input. So we really don't need this to be an array. I think this can become a hurdle when we get the actual input.
Yeah.
And now the prediction, instead of appending, we just add,
sum the
and then we
value.
can just print the prediction. And in our case,
Yep.
it should be 114. Is it?
1 1.
Oh.
No.
No, so
It's
we
going-
are doing it line by line. So prediction is
Yeah.
just line by line.
No, I
So what we
mean
can
do
do
the
now,
print outside of the for loop.
we do the prediction as a global variable. Oh no, yeah, it's starting in 0,
But you need to update that
then-
inside of the loop.
and then each line adds predictions on the numbers -1,
Yes.
right? And then we show
Yep.
we print prediction outside the loop and outside
Yep.
reading the file.
Yep.
And now we should have 114. Cross your fingers.
Fingers crossed.
Yeah, 114. There we go.
Woohoo! Now run the
We
phone.
made it. And now what always happens? I download
Everything
it
is wrong.
and it breaks.
That what happens to me every time. Because I never think of all of the edge cases by myself.
Yeah. Alright, so we got a big
It's a
number.
long number.
I don't know, it was fast.
It doesn't mean it's not
We pasted in
wrong.
the answer. Any final words? Predictions? Do you wanna guess?
It's wrong. It's wrong. Go. It's going to be wrong. It's always wrong the first time around.
No.
See? Is it too high? Or is it too low? Not that it's making any difference, but
Oh,
what did he say? I didn't read, sorry.
I didn't look.
That's what I'm saying, dude. Now the real fun begins. How do you figure out the right answer?
Maybe we did a mess with this prediction thing.
What do you mean?
Let's roll back the prediction. Optimization.
Mm-hmm.
This was getting us to the 114.
Yes. We didn't run like the example with what is the name? Oh, it's snowing. Sorry, I got distracted. We didn't run the optimization with the example, the short one that we had, right? After the optimization.
I reverted to the sample one.
Yeah.
And now what we're gonna do is I normally have a variable here, result part 1 equals 0, and then at the end of each line,
You print it.
we add the predictions, right?
Mm-hmm.
Let's call this also prediction for line. Is that a better name?
I think so.
For input. All right, and then we can. So this should be still. Well, this should be inside the for loop, right?
Yeah.
All right, it's inside the for loop, outside the while. So it's a solution for the line. And then
Print the result part 1 and run with the sample.
Then we run it. 114.
Okay.
Right. Let's bring back the demon. And let's.
Now, is this the same number you had before? I think it's the same number.
It's the same number. So the good thing is our optimization was right.
Okay.
Optimization between quotes doesn't really matter. But the bad thing is still broken.
Oh yes, and we are 1 hour into this live stream, and we have like half an hour to try to figure out what's wrong.
We'll do it faster.
I'm
So
hoping.
normally, because I seriously have no idea where
I have hope.
to look, so we can go and look into the inputs.
Oh, so they have
So
negative numbers there. See, that's a good sign.
that's a good sign.
Yeah, you were right
Oh, yeah.
when you were thinking. Like I would never have thought of having negative numbers in the input.
So that could break this.
Probably.
Everywhere we have a 0.
Everywhere we compare bigger than 0, probably, yes.
Yeah. If so we will escape beforehand.
Do different than 0 then.
Different than 0, right? Yeah.
Yeah, because if it is 0, we want it, right?
Yep.
Oh, the number changed.
Should I run it? I need to wait 46 seconds.
Oh my dear Lord. Why?
I don't know. You need to wait sometimes when you give the wrong answer.
46 seconds. Can we do a countdown? I want to run a countdown.
I normally bombard it, but then it doesn't. At some point, it doesn't like it. And then you are penalized even more.
Oh dear Lord. Just wait. It's better to wait.
There's an exponential back off, so people doesn't brute force the answers. Yeah, I think that's that kind of like what happened here.
Yes. I asked why, but I kind of knew the answer. It's just like...
All right. 5 seconds. 4, 3, 2, 1. Did I count it too fast?
Yes.
You give the right answer. Yeah, we got a gold star. All right. Part 2.
Yes, now's the time. Woohoo!
Part 2. No. What happened now? Of course, it would be nice.
I'm always scared of part 2.
Surely, it's safe to just extrapolate backward as well, right? For each history, repeat the process of finding differences until the sequence of differences is entirely 0. Then, rather than adding a 0 to the end and filling the next values of the previous sequence, you should instead add a 0 at the beginning of your sequence of zeros. In particular, here's what the third example history looks when. So you have 5, 10, all this stuff, and then you have 5, 3, 5, okay. So this is the same thing, right? It's the differences. It's always calculating the differences.
Yes.
But now we are adding values to the left.
Oh dear.
Well, easy. It's the same thing. Oh no, this cannot be.
How the heck is this the same thing?
So
like I mean, I understand changing the index of the list to whatever, like 1, like 0, no 1, 0.
Look, I'll show you the secret sauce. We know how to calculate this, right?
Okay.
To put the next one to the right?
Yeah.
What happened if now I give you, with the same algorithm we had, this list?
Mm-hmm. Okay.
We know how to calculate it, right? Like we did before with the same algorithm. We can calculate.
Oh, I see. You are reversing the list. Okay,
We'll reverse the list and we run the same algorithm.
Steve got there faster than I am. In my defense, I haven't eaten any breakfast, and my brain does not function properly if I don't have food. You know, so I'm here just to be in the way and make comments like I am 3 years old. But anyways, yes, it makes sense. Oh my God, you're so smart.
Mm-hmm. All right, so now we have a function that returns the prediction for the line. And now results part one is equals to, what do we call the function? Process
What do
alt.
you what?
Very,
Why you doing that?
because we need, if you have a function, we can call it for the two of them, right?
No, wait, stop. Give me a second. Why instead of using a function, don't you use like dot reverse or something for the list?
I want to keep the results of part one and part two on the same file.
Oh, I
So
see
don't
what you
write the
mean.
other
Okay,
one.
yeah. Don't mind me.
Yeah, so now,
What I
if I
do
run
is
it,
usually do a different file. That's why I was like, what?
oh, if I try to avoid it, I avoid it. And in this case, it's as simple as doing part two
Mm-hmm.
minus one. Is that the best way to inverse an
That
array
is
in Python?
dot
This
reverse.
is my preferred way, but there's people who use
If
a
you
function. I
do-
don't remember.
You do list dot, I guess with reverse or reversed is going to give you the reversed.
Okay.
Can you try that in the console? Just so we can see it.
So I create an array 1, 2, 3, and then I can do a dot reverse.
And then do A.
Now,
Yep.
And now it's reversed. Or I can
Yes.
do
It's
a
just the only thing is in place.
minus one.
Yeah. So for
Yeah.
example, what I would do if you
Mhm.
want to have the list itself, I would do the column minus one, because then you have the list as a result. But if you want to do
Yeah.
in place, I would do reverse.
Okay, yeah, that makes sense. Okay, then in this case we leave it like that. And
Yeah.
now I don't believe this is so easy, but we'll see. So that's a weird low number.
Steve said like there's also reverse function, yes. And we are by using the range syntax drops into C code, so it's fast. Like I mean, we're not terribly worried about speediness, but yeah. Like I went the other way around, which my pro cons is about what is the easiest way that you can get the thing you want, which is basically if you want to have a list, do the range syntax instead.
So I'm surprised the number is extremely low this time.
No.
I mean, will I try?
Yes.
I'm skeptical, but we don't have much time, so.
Submit. Oh,
that's
course.
not right. It's too low. Are we using the full data?
Yes.
We are using the full data.
Is the reverse process working? Like as we expected to?
Let's input this and find out.
Yeah.
So part 4 now is minus 4, and it should be 5.
See? That's what I'm saying.
Oh, rather than adding a 0 to the end and filling the next values of each previous sequence, look at this. For each history, repeat the process of finding differences until the sequence of differences is entirely 0.
Yes.
We cannot just look at the last one.
Yes.
So we need to do the set question now.
Yes.
Instead of this. I wonder if this will affect our initial solution. Let's try. Maybe it doesn't affect the first solution. So set of numbers
set of numbers, the length of the set needs to be bigger than 1.
No, but it needs to be all 0, right?
Okay, so instead of, I see what your point. Like the value of the set needs to be 0.
Like if I have set of an array which has 0, 0, right?
Yeah. So that needs to do that
Is
and do
that
dot value.
is that equal to this? No.
No. But if you do the set instead of the square brackets, do the curly brackets, it might be the same thing. Catch my drift? Yep. Because a set is different than a list.
Yeah. Oh, okay.
Got it.
If I now I get the full input, but now we broke part 1.
Yes.
So part 1 and part 2 require different conditions.
Yes. Let's do a separate file in the interest of time.
In the interest of time, yeah.
Yes, because we have.
Well, I can just copy
90 minutes. Yeah, copy what you did because part 2
Let me
is
see if
working.
it's fine.
Oh yeah, good idea.
That's not the right answer. Your answer is too high.
Now it's too high. Oh dear Lord.
Or somewhere in between then.
Yeah. Nonetheless, I would copy the thing into a different file, or at least do a second part of copy the code that you have as a second part, and then do the print separately. Oh, wrong place.
Oh. Yeah. So part 2.py, and then this one will be part 1.py. And we get rid of this.
You need to also undo the.
Okay, so now part 1 is still broken.
Part 1 wrong.
Oh, because
it's the set part. Yeah.
Well, what did we have here?
We had numbers
-1 different than 0.
Yes. Yeah.
Yeah, that sounds about right.
Yep.
All right, so part 1 now is fine, and now part 2. I'm just copying the same.
Mm-hmm.
So for part 2, we said that we need to process it in burst. And this number, no. Part 2.py. This number is too low.
Yeah.
And now if we do the set,
that one's too high. Equal, no?
That one is too high.
Equal. Oh no, different. Oh yeah, different. Sorry. Never mind me.
Yeah.
Continue. Why the heck is this?
There's gotta be another. Well, doing this for the reminding example data. So, hold on. I'm not adding new values to the left side of each sequence from bottom to top eventually reveals the new leftmost history value 5. 5, I understand. Like this one. We are calculating that one, right? When we just input this file, we're getting -4.
Which
They're
one?
not getting 5.
Okay. So, but we did a different thing, right?
No, because 5 is not
Yes.
part of the 5.
Yeah.
Okay, so we get 5. And then it says, okay, so doing this for the remaining example data above results in previous values of -3 for the first history and 0 for the second history.
Okay, so you can use the simple, like the first sample, and check the sample. Use the first one that we have, like the one in the beginning, like the 3 lines. Yeah, those. Use those to check.
So now it returns
but then again, 2. you need to print out the values. Your values together produces 2, yeah. But print out the values just to make sure that they are not doing some weird math thing. Like in the for loop, print out the value for each one.
-3, 0,
0,
and 5. It's fine.
Yeah, that's right. Oh dear Lord. What happens?
Let me put the whole input again.
Just in case. What? How?
Oh,
what?
Yeah.
Oh.
1, 2, 1, 1. But this was too high, right?
Yes, this one was too high.
I feel like trying it again.
I mean, part 2 is always harder. Maybe what got
Maybe
wrong?
they got it wrong.
Now you are in negotiating.
At this point, I'm just in denial.
Yeah. There's no way that this is not right.
There's no way. No.
The worst thing is I don't have any idea what could be right. Like, what is like the thing that we need to fix? It's something really small. Because the difference between like one and the other is like 10.
It's 10.
Yes.
There's an edge case that we have here that we didn't contemplate.
Yes.
So let's see, that is 1 producing an output of 10.
Or something that it is 10-ish. Together with like a minus something from the other line.
But it could be 2 or 3 that add to 10. We'll never know. For each history, repeat the process of finding differences until the sequence of differences is entirely 0. Then, rather than adding a 0 to the end and filling the next value of the previous sequence, you should
What if one of the sequences that we have is not entirely 0? Would that, like, remember that example that you had, which was 1, 21, 22, 23, 25? That the last one that we had was not entirely 0. Would that count as the last one in our algorithm?
Sure. But we don't have anything like that here.
No, yeah. Put that into, like, we don't know. Change the inputs to the sample like that we had. That we double checked everything.
This one.
Yeah. See what that gives out as a result. Oop. What?
Okay, now it breaks.
I don't get what did you get like the out of index?
Prediction for line.
If you run with the sample code, it's right. It's functioning, right? This is
So
before when you
we start with this,
yeah.
then we have this, then this. Oh, this because ends in -20.
Yeah.
Oh, this is a 1. If it's 0, if the len is 0, we shouldn't even enter inside because this doesn't make sense.
No, it has to be equal.
There
It
has to
should
be at
be
least one item.
so equals bigger or equal to 1, right?
Yeah, no, that's fine. It's gotta be at least. So this is now -100.
No, the while needs to be fixed. Like, because if it is 1, it's not going to be it in. You still need to run for 1, right?
Well, if it's 1, like if it's -20, you just take the -20. And this is what this is doing, right? So when it arrives to the
I don't get what you're
-20,
saying.
like if you have 1 here, -20, it will just take the -20. Or you want to
Okay.
put a 2 here?
No, I wanted to put like bigger than 0 or
No,
which
the
was
problem
before,
with 0,
right?
because the case where it's 0,
Mm.
so bigger than 0 is what was before. The problem is when this is 1, for example. Now the list is empty, because if these numbers contains only 1 element, right? It passes through here, but when it comes to numbers here, this is now 0.
Oh, I see your point.
It's empty.
So you need to go into it before.
Yeah, because we check before we process.
Yeah. Makes sense.
But I don't know. Yeah, this is.
Is that right? That's my point. Run it again with the example.
I'm not sure if it's gonna make a difference. No, it didn't make a difference.
Yeah.
There's gotta be a small
thing that we missing.
detail.
Yeah.
Somewhere. It would be good, like, to send like all these lines and then like give you some clues instead of just.
If we put the input and say like, oh, this is something that might go wrong, but that is way too hard to implement as well. And you would have to run something on top of the code, and then people could,
You can run tests that tells you
Yes.
which index you got the error.
But would we know?
The same way they check in which index they the sum, right?
Yeah. Anyway.
Let's try what you were saying here. The len. What was it?
I don't remember anymore.
Instead of comparing that 0, which I don't like so much,
Yeah.
I get the same result.
It's going to be it's going to function the same way.
I was hoping. I had hopes.
You had hopes. I did too, unfortunately. Oh dear. And you know what I think is we have been at this thing and like for 1 hour and 25 minutes now.
Oh, that's the right answer.
What? Why did it go wrong then?
1 2 1 1 is the right answer. Did we gotta make a difference?
Could we have? Okay, so maybe something that you did is when you copied over, it had like a blank space on it.
Oh, come on.
And then
There you go. Solved.
Solved. Don't question it. And just in time, we have like 5 minutes to end of the stream. Great.
There you go.
This was good.
Good. Really? Look at that. Too high.
I guess he had a blank space and then they compared like with the blank space and then something went wrong.
Oh, God.
Oh, dear.
I hate this. All right, let's beautify.
So
So
funny.
now,
You have 5 minutes. Commit to the answers and get on with it.
look at that. Now we can do.
No, you did it wrong. You you did it wrong.
No, I did it fine because look, we can solve it in one.
No, what I mean is, oh, I see what your point.
No, because now I
Yeah.
won
You were
the
just
thing.
double checking that the first result was the same.
Yeah.
Never mind me.
So now, if I run main.py, oh no, forget about it.
Wrong.
Oh no, with the new condition, right? Because
Yeah, we need to fix the condition there.
we have here the len condition. There we go. So solution 1 has the same result, and solution 2 has the other.
Yeah. Yoo-hoo!
And we can do it in one fight.
Great! Awesome.
That was weird. We
Yes,
could have
I don't
spent
know.
so many hours thinking about it.
Yes, I'm assuming you had like
Or
a
at
blank
least
space when
few
you
moments.
submitted and it was counting with the blank space and something went wrong.
Yeah, but yeah. So this is great. So
Yep.
now. you can do it.
Woohoo! Commit. You know, if you want people to see you committing, you need to like increase your font size.
I don't know. This is such a personal thing. But I guess if we are here already,
Oh, I mean, you know. Will I judge you? I won't, I promise. Tony celebrating with us. Hands up. Hi, Tony.
we also need to thank Steve.
Thanks, Steve.
Oh,
You missed the code. Just close the code.
all right, there we go.
Woohoo!
It's on the way. Oh, authorized touch ID. I guess that's fine. Yeah, there we go. Solution is already available on GitHub. For everybody here who has been following, you can check our solution, our final solution there in just one file. Yeah,
Yes.
this has been fantastic. Yeah, thanks a lot. Thanks, Steve.
Okay,
and
since I
everybody who
helped,
joined today.
since I helped code this, it is fair if I run this to my input and submit my answers? I kind of
Absolutely.
helped out, right? I guess it
Absolutely.
counts.
You are key. You were a key instrument on finding
Yes.
the solution. Like I didn't have that conditional, for example. That end conditional was key for our success. My pyramid theory became obsolete at the moment of part 2 appeared.
Oh, that's great. We managed it. Thanks everyone who joined and was here and, you know, kept watching us struggle through this. Especially me.
Thanks everybody for having us. It's been a pleasure.
Yeah.
See you on the next time.
Bye.
Bye.